All right, so in 8.2, we're going to look at finding the area between two curves. So before we get started, try not to like peek ahead in your book right there. I just want you to look at this problem right here and try to come up with a way that we could find the area between that curve f of x and that curve g of x, a part that's shaded right there. Now we know how to find the area between a curve and the x-axis, right? That's a definite integral, but I want to think about the area between the curves. So to pause this for just a second and see if you can come up with an idea, and then we'll come back and talk about it. So if you look at this, if it makes sense, if I found the definite integral from a to b of f of x, right, that would be the area under that curve right there, you know, that area I'm shading in blue right there all the way across. And then if I took the area of g of x, so the area into that curve, you know, think about that area going that way. If I subtracted off that area, so minus the area from a to b of g of x, right, what would I be left with? Well, I'd be left with this area right up here, and that's what we're looking for. So really simple, when we try to find the area between two curves, all we do is take the upper function f of x, take the definite integral to find the area, minus the bottom function g of x. And when you subtract them, you end up with the area that's left over. So now, if you look at your notes there, right, we have that same picture and area of the region between the curves right here. All I do is take my upper function f of x minus my lower function g of x. Now, make sure this is important. That works as long as f of x is always greater than g of x. In other words, f of x is always above it, right? F of x is the top function, g of x is the bottom function. Now, sometimes those functions might cross, and later on, we'll go through an example and kind of show you what happens with that. One really important thing, if you're asked to find area is always positive. So when you get these answers, your answer always ought to be positive. Now, that's a little confusing because we said when you take a definite integral, you do the signed area. If it's above the x-axis, it's positive. If it's below the x-axis, it's negative. We're not asking you to find a definite integral here. We're asking you to find the area. So if I ask you just to find the area, it's got to be positive. Area is always positive. So you'll see what these answers should always come out to be positive. Now, a really important thing is most of the stuff we've dealt with this year have been functions of x. So they've been functions. If that's the case, it's always going to be top curve minus the bottom curve. Sometimes we'll deal with things that are functions of y. So if you look down here, it's right, functions of y. When you do that, it's going to end up being the right curve minus the left curve. Okay, notice how instead of being dx, it's dy. And then also your limits up here, put a little star by this. Your limits have to be in terms of y too. So have to be in terms of y. And I'll show you what that looks like on an example here. So the limit has to be in terms of y. And I'll show you what that looks like here in just a second. So that's a little bit different. An example of that, just real quick, is a function that's in terms of y instead of x, right? Y equals x squared is a function of x. It looks like this. If I switch those around and go x equals y squared, now that's a function of y. It's in terms of y, and it looks like a sideways parabola going that way. And you'll see that a lot. That's actually probably the most common problem you have is a function that's when it's in terms of y, is a parabola. There are some others, and we'll see some examples throughout, with what we're going through here and also on your assignment. Okay, so let's do a problem. So this one says, find the area of the region bounded by y equals x squared plus 2, y equals x equals 0, and x equals 1. And they were nice enough to already graph it for us, right? Here is y equals x squared plus 2. There is y equals x. And x equals 0 is that line, x equals 1 is that line. So that's the area I'm trying to find. Well, these functions are in terms of x. And also notice I have my top function and I have my bottom function. So when I set this up, it's going to look like this. I'm going to go the definite integral of my top function, x squared plus 2, minus my bottom function, which is just x, dx. And we're going to integrate from 0 to 1. Okay, let's find out what this is actually equal to. Oh, but 0 to 1 came from, right? I'm starting at 0, and I'm going to where x is 1, right there. Okay, let's go ahead and integrate this. The parentheses inside there don't really matter, right? If I integrate x squared, it'd be x cubed over 3. Integrate 2 would just be 2x. Integrate the x would be minus x squared over 2. And then we're going to evaluate that from 0 to 1. Okay, plug in 1. That'd be 1/3 plus 2 minus a half minus, plug in 0. That'd be 0, 0, 0. So it just ends up being 0. We could, you could work out those fractions, or you can just leave it like that. But that would be the area between those two curves. It definitely comes out to be a positive, which it should. Sometimes you'll have it where when your boundaries are set by where two graphs intersect at. When that happens, you have to find where they intersect. That gives you the upper and lower limit when you integrate. I'll show you an example of that next. But this is important. On your AP test, you have to show an equation. You have to set up the equations, even if you're using a calculator, to show how you found the intersections. And again, this will make more sense when I show you what it looks like. Okay, so these are a little bit different. If you look at this equation, this function is not a function of x, it's a function of y, right? I have x equals stuff with y in it. This one actually is in terms, this is a function of x, but we can switch that around. If I minus the 1 over, I get x equals y minus 1. So now they're both in terms of y. They're both functions of y. And we want to find the area of the region bounded by those two. So let's start by drawing a graph. Y equals x squared is a parabola that's facing up. So x equals y squared is a parabola, and the y squared is positive, which means it's facing to the right. Now, if I add or subtract y equals x squared, it moves it up or down. But because my x equals y squared is horizontal, when I add or subtract on the outside, it moves it left or right. So the minus 3 is just going to move it to the left 3. That's my vertex right there. Then if I go over 1, up 1, over 1, up 1, my parabola is looking something like that. Then I want to graph. I'm going to use this equation, the original one, just to graph it. But y equals x plus 1, right? I crosses at 1. I go up 1 over 1. So it's looking something like that. Okay, because they're in terms of y, instead of going top minus the bottom, we're going to go right minus left. So if you look at it this way, if you're thinking this direction, right, the right side is this x equals y minus 1. That's the right side. So when I set up my definite integral, it's going to be y minus 1 minus, and then the left side would be this function over here, which was the y squared minus 3. Make sure it's a dy because it's in terms of y. Okay, this is a little bit tricky. Normally, when it's in terms of x, we go from left to right with our limits. When it's in terms of y, I go from the bottom to the top. So in other words, I want to know what the y value is right here. I'll make it a different color. I want to know what the y value is right there at that point. It looks like -1, pretty close to it. And I want to know what that y value is there. It looks like it might be 2. But we need to find those exact values. So this is what I was talking about in that last note we just wrote down. When you have to find where the two graphs intersect, right there and right there, you need to show how you found the point where they intersect. Well, the way you do that is you just set the two equations equal. So I'm going to take y minus 1 and find out when it's equal to y squared minus 3. So that note we just did was talking about this equation right here. This is the equation that will tell me what this y value is and what that y value is. It'll tell me what my two limits are. That's what it's going to tell us. So you have to show this equation. Even if you're going to use, some problems will be calculator problems. We'll do one in a second. If you're doing a calculator problem, you still have to show the equation you're setting up to find those. Okay, let's actually solve this by hand, this one though. So I'm going to minus the 1 over and minus the y over and add the 1 over. You end up with 0 equals y squared. If I minus the y over, if I add the 1, we get that. Do your two sets of parentheses. Y and y would be factors of -2, that would be -1, so -2 or +1. So we end up getting y equals 2 and y equals -1. And that's what I'm looking for. Because it's in terms of y, I want the y value. And that fits our graph. That's what it looked like. It looks like that y value is -1 right there. It looks like that y value is a +2. So I come over here. I'm going from a -1 to a +2. Okay, now we're all set to integrate this. I'm going to simplify that inside a little bit. So we'll go from -1 to 2. I'm going to have y minus 1 minus y squared plus 3. So -1 plus 3 is a +2. I think we got it all there. I just combined some like terms there before I integrate. Hey, go ahead and integrate it. I would have negative y cubed over 3 plus 2y plus y squared over 2. Oops, sorry, I forgot to draw my line there. And I'm integrating it from negative 1 to 2. So if I plug 2 in, that would be negative 8/3. Plug 2 in there would be 4. Plug 2 in the next one. 2 squared is 4 divided by 2 is 2. Minus, plug negative 1 in. Negative 1 cubed is negative 1. There's already a negative, so changes to positive 1. Negative 1 in there would be negative 2. Negative 1 in there would be plus a half. Okay. Whatever that comes out to be, this whole thing, whatever that comes out to be is my answer. Okay, so a little bit tricky. If it's in terms of y, you got to make sure you go right minus left. And the other really important thing is you got to find, if it doesn't give you what your bounds are, you've got to find those. So if it's in terms of y, you got to go from the bottom to the top, from negative 1 to 2, right? From there to there is where we're looking. And you have to show how you found negative 1 and 2. That was by solving, setting the equations equal and finding out when they were equal to each other. All right, let's do this one right here. So this is the kind of the one I was talking about where I said sometimes they cross. So if you look at this one, f of x is the x cubed minus x squared. I'm going to change the color a little bit. I'm going to do it in red. So that was f of x. G of x is that parabola. So it looks like this. So that's g of x. Now, what you notice is, remember we said this rule only works if f of x is always on top. And so what we're going to do is we're going to split this right here. And on the left side, I'll take f of x, right, the red one, minus g of x, the blue one. But then when I get over here, I've got to switch it. On the second part, I've got to take g of x on top, and I've got to take f of x on the bottom. Okay, so this is what my integral is going to look like. My first one, and I haven't found the limits yet, we'll do that in a second, is going to be f of x minus g of x. And that goes from something, it looks like they cross at 0 there in the center. So it's going to go from something to 0. I'm not sure what that x value is right there. It looks like pretty close to negative 2. And then the second half, the second piece of area, I'm going to have to go from 0 to wherever they cross right up there. So that's going to be from 0 to something. And this time it's g of x minus f of x. The only thing I'm really missing is I need to know, like, where exactly do those two cross there, and where exactly do those two cross there. And I may want to find out where those cross right there also. So to find that, grab a calculator. And I'm not going to show you the calculator up here just because every time I do, my smartboard program freezes up. So all I'm going to do, and we've done this a lot before, so I'm going to go into y equals, and I'm going to put those two functions in there. So I'm going to put x cubed minus x squared. And my second function is a negative x squared plus 4.1x. Okay, now you have a choice. You can either graph those two and find their intersections. You can go to the calculate menu and find their intersections. Or the other option is, you can also do this actually, right? And write this down. This is what you have to show. You have to show how you find those points of intersection. So somewhere on your paper, you need to say, hey, I took x cubed minus x squared and set it equal to negative x squared plus 4.1x. So you need to show that somewhere. If you want to in your calculator, you could just get everything on one side. So add the x squared over minus the 4.1x over. And you could graph this and find the zeros that way if you wanted to. Or you can graph them separately and then just find where they intersect at. But it's important that you show this step right here. You have to show that top equation, like that's part of your work. So I'm just going to do the intersection. So I'm going to go to my graph. So I have those two both in there. I have them both graphed. And then I'm going to go to the calculate menu. And I'm looking for the intersection It asks you for the first curve, you just hit enter on that. Second curve, just hit enter. Then it says to guess. I'm going to find the one down here on the left. So you got to move your cursor down there by it. You'll find the one you're closest to and hit enter. And the intersection point comes out to be negative 2.024 and negative 12.401. Now, all I care about is the x because we're in terms of x. So we're going from negative 2.0 to negative 2.024. And if you do the intersection on that one, it does come out to be 0. So I'm going to put this down here. You can actually store that number also. And the way you do that is if you just hit enter, and then you get out, and you go into the main screen, and you hit store, it will take the x coordinate and it will store it, with a name, with a variable. So you can store it, or you can just put it in like that. Okay, you guys go ahead and pause the video, and just make sure you can find out where those two intersect at. What is the x value? And then come back and we'll finish this up. So you should have gotten that the x value there is actually a positive 2.028. So this is the problem that would give me the answer that we're looking for. By the way, when you're on the AP test, you don't have to write out the actual function. So if you want to just leave it as f of x minus g of x and g of x minus f of x, that's fine. Up above, it tells you what f of x and what g of x is. So from there, you just punch that whole thing in your calculator. So you guys can go ahead and try that. By the way, just remember, if you did put f of x in your calculator, if it's under as y1, you don't have to retype it. You can just put it in as, you can go to vars, to variables. It's right below like the up or down arrow signs on your calculator there. And then you can select y1, and for g, if you put g of x in as y2, you could do that. And then you don't have to retype them again. You can just use what you already put in when you graphed them and found their points of intersection. Anyway, plug that whole thing in there. It will take the calculator a minute. It will have to think for a little bit before it will actually find it. Wait, that will give you the answer. I'll tell you the area between the curve. Okay, so the really important things are, if it's in terms of x, we do the top minus the bottom. And your bounds also have to be the x values of where they cross at. If you do it in terms of y, it's got to be right minus left. Bounds will be set by the y values instead of the x values. Other than that, I mean, this is pretty basic. Hopefully this made sense. Work on the assignment, and if you have questions, let me know, and I'll help you with them. Thanks, guys.